Okay, so this is part two of our vegetation notes for Pacific Northwest geography. And we got to plant succession, and I told you we'd get back to it later, and we will eventually. Um, but what I want to do is circle back to a theme earlier on, and that is this crazy tree called Pacific Madrone, and how many of its genus are found in all along the west coast, all the way up into British Columbia. That's one species, the Pacific Madrone, all the way along the Pacific coast of the United States and well into Canada and the drier interior areas of Western Canada, Western British Columbia. But also, I wanted to look at just to kind of highlight this once more as we kind of introduce this next unit. I wanted to have a peek at this pinguica that I mentioned, and I didn't really do that story justice in my introduction. But what happened at the story I have is that this tree is actually it's kind of a bush, really. It's manzanita. Is It's got several species in Mexico and also here in the Pacific Northwest. And so my mother-in-law is from Mexico, and my wife and we were camping up on the kind of along the flanks of Mount Hood, not that far above Parkdale. And we just kind of went out and kind of hiked around a little bit. And all of a sudden, my wife and her mom started saying "pinguicas, pinguicas," and so I went up and looked, and so they started pulling off, and they're kind of like a berry, but they're like you could kind of like a flower, hard stuff. You kind of almost like a nut, really. And so they were chewing them, and they said they were almost identical to what we see here in central Mexico. This is the region that you find a lot of these, and that one of those photos, in fact, came from there. And so this is a kind of a big story because how on earth do we have a plant so similar in these different areas? Okay, so coming then back to our notes, um, I want to go back here and then look what do manzanitas have in common with the Pacific Madrone? And why are Pacific madrone or similar madrones found throughout much of Mexico and highland areas? What's going on there? So there is a geohistorical background, which is one of our earliest factors. There are geohistorical factors that we will look at here. Um, the kind of simple statement is that the current flora, in other words, the plants in the Pacific Northwest, are descendants of the regional geofloras that developed during the Tertiary period of 3 to about 65 million years ago. Okay, so let's have a look at this. What are we talking about? Regional geofloras, okay? So what this map shows, and this has been out, I think this came out in 1958, originally, the article, where some of this research was summarized, and there's been lots of work on it since then. But check it out. Okay, where are we? All right, so this is Oregon, Washington, Idaho, British Columbia. And you can see that there are, broadly speaking, two geoflora, which is just a kind of large geographic area of plants, a plant community corresponding to a particular kind of environment. And the arcto, what does that sound like to you? Right, so kind of Arctic or at least temperate. The tertiary is just the time frame going way, way back. Um, and so there's an arcto-tertiary, and then there's a neotropical tertiary. And then there's kind of a boundary between these two. And you might recall that the region was just really starting to form here. So there was a sea in this area, and then there's a sea retreating rapidly in the interior. You might remember that from the first unit. And so here we are, though, with two different geoflora kind of competing in the region. And in fact, when it would get colder, then the Arcto-Tertiary would move this direction, and then when it would get warmer, it favored the movement in this direction of the neotropical tertiary geoflora. But particular, I want to point out to you the ancestral Madro-Tertiary populations. Okay, this today, this region is one of the three most biodiverse regions on the planet. It is the enormous load of biodiversity in these mountains, ranging from a little over 8,000 feet down almost to sea level. They have kind of their own Grand Canyon, which has even greater change in elevation from top to bottom. And at the kind of down low, it's kind of subtropical plants, and up high, they're more drought adapted plants. You'll see a lot of them that are familiar here, and that's why. Okay, but in this whole region, then this has been long been a mother lode diversity. You can say emanating out from it into much of the rest of Mexico, south to the west, to the northwest, to the northeast. You have this spread of these populations that evolved in this particular region. Okay, so these two geofloras, broadly speaking, arcto and neotropical. Within that neotropical is the ancestral Madro-Tertiary, which is the most influential of them. Okay, and so what you might notice even now is that there's this presence that goes way back into the region of this neotropical tertiary geoflora at large. And so let's then go back to our outline. And so what we're talking about then is that these arid environment plants are from the Madro-Tertiary geoflora. That's the dry subtropical climate of the Sierra Madre of Mexico, and the temperate forest plants from the Arcto-Tertiary. Okay. Now, when you think of that, you kind of have to consider too that there's a lot of other things happening. You might remember we're building mountains, and especially we looked at the Coast Range and the Cascades. We can include the rise of the Sierra Nevada in this. For those of you who like to include Northern California in our story, and in this part of the story, they have to be there because this is part of what happened. The rise of these mountain systems led to increased aridity, or if you will, dryness in interior areas, right? So you build some big mountains that keep the Pacific moisture out of the interior, you make it drier. Okay, what does that favor? It favors the geoflora that can handle drier, okay? And so there was a replacement then when this happened of the Arcto-Tertiary with the Madro-Tertiary geoflora, okay? And so this is a big story in the Pacific Northwest. And what I want to do now is pick up that story in a little more detail. So this is an outline, and I will post this one online, but I want to go through it with you quickly. The Madro-Tertiary geoflora of the Pacific Northwest. Beginning about 65 million years ago, the climate of Western North America began to cool and became more arid, partly due to falling global temperatures and increasing global aridity. Okay. And partly in response to the initial uplift of the Sierra Nevada and Coast Range. Okay, so we have the aridity because of the mountains, and there was a general global climate cooling that happened during this time period. I won't get into the causes of that in this, but if you take a climate change class, you'll probably learn more about that. We just don't have time. But the rain shadow that resulted from these mountain barriers allowed then that Madro-Tertiary geoflora from the Sierra Madre of Mexico, where we've looked at it, to expand its range and replace some of the Arcto-Tertiary plants in California, the Columbia Plateau, remember the big basalt plateau dominating Washington State, parts of Oregon, okay, and Western Washington also, and Western Oregon and Western Washington, both, okay. Subsequent uplift of the Cascades increased the rain shadow effect in the interior, especially in the last 20 million years, okay? And so the rain shadow effects of the Olympic Mountains and Vancouver Island have created enough aridity for some of the drought-adapted Madro-Tertiary geoflora to extend well into Western Canada, including the northern sector of the Salish Sea, the Strait of Georgia. And so really interesting map that shows us that distribution here. I'm just, oh, here it is. Check this out. This is, okay, so this is Washington State here. This is British Columbia. And wow, so that's Vancouver Island, one of those terrains docked on the side of the continent, a microcontinent really. And Vancouver here, the main city. And this whole area here, the light green color, or the green colors here, are areas where you can find that Pacific madrone, which is a migrant all the way up from Mexico. A tree migrant, okay? So the range of this is really amazing. I mean, all along our Pacific coast. I just wanted to emphasize that as a point here. Now, that's the Strait of that Salish Sea, that interior area there is the one I was referring to there, okay? Most of the plants of the Madro Tertiary geoflora in the Pacific Northwest are drought adapted with some combination of small, deciduous, or waxy leaves. Okay, so why small? Why is that drought adapted? Less surface area to lose moisture through transpiration. Deciduous, what does that mean? Deciduous means it loses its leaves during part of the year as a drought mitigation strategy. And what would waxy leaves, how would that help? Okay, if you're in a dry area. The wax, of course, keeps the moisture from leaving so much. So these plants tend to have some combination of these strategies here in the Pacific Northwest. Now, you can find, as we point out with the Pacific madrone, some are in fairly high precipitation zones, such as the coast, and you can find manzanitas along the coast in some places too. And that usually happens when you have coarse grain, like sandy soils, ones especially with minimal moisture holding capacity. And that one on the San Juan Islands was an example of that. But you can also find these in some places on the Oregon coast. Usually it's in sandy soils, south slopes, that sort of thing. And they literally grow on our very wet Oregon coast because it's so dry there in the summer that if you're in an area of coarse sediments and south slopes, literally there is a drought stress even at the coast. Okay, so that's not a new thing, and the madrone particularly is adapted to that. Okay, now here's some plants to know. And this is really an interesting list, just to be familiar with it. Madrone, we've already showed you a picture of, talked about it, and its cousin in Mexico. They grow, well, we didn't actually give you a photo of those, but the manzanita we did, though, the Arctostaphylos, that's a genus, and there are several of these in Oregon and Washington, and also in Mexico, and some of them very, very similar to the pinguicas we mentioned, okay? There's the Western juniper, okay? And now here's what's interesting. A whole bunch of if you go east of the Cascades, you go to Bend, Oregon, you will find most of, other than the ponderosa pines, other than those, most of the plants you see in some places are from this Madro Tertiary geoflora. This is the major one, the Western juniper. Okay, what do those look like? Let me give you a quick look at those. Those are here. That's a Western juniper. Okay, so you recognize this environment. This is kind of the classic Central Oregon, North Central Oregon, even some parts of Eastern Oregon. You see these parts of Washington State as well. The Western juniper, that's kind of far away, how they look kind of scattered around. We're going to come to those later, but these are drought adapted. But look in the foreground here. The sages, the bunch grasses, these are all Madro Tertiary geoflora. This is like being, in some ways, in some areas transitional to the Sierra Madre Occidental, or the Western Sierra Madres in Mexico. Very much so, okay? So it's almost like being home if you're from some of those areas, okay? And so the junipers are kind of the classic one, but most of the bushes are this kind of drought adapted, the bunch grass, same way, okay? Some of the wildflowers. So it's there's even succulent cacti in some areas that grow here in the interior areas. So you have a very expansive one, okay? And these are all very different from what you thought I was going to talk about. And we will get to these, okay? This is a big part of our story. The rainforest giants, the Sitka spruce, the Douglas fir, the western red cedar, the western hemlock, the mountain hemlock. This is all up in the Quinault Valley, by the way, in the Olympic Peninsula. And of course, the classic western red cedar, though, that's really the one of the most beautiful trees in the Northwest, okay? That's where you thought I was going with this originally, and we'll get there, okay? But I wanted to kind of take this little detour because it's really, really enormously important, especially in our interior areas, okay? So a few more. Poison oak, okay? Wow, boy, those, okay? Those are part of the geoflora, all from Mexico, madrone, the manzanita, the western juniper, the poison oak, the Oregon white oak. This is the dominant tree in the Willamette Valley in areas that, especially in the drier kind of, rocky forests on the slopes. But we'll find out that a big part of the reason why the Oregon white oak is such an important tree is because of fire management of the area. Okay, and then I mentioned the bunch grasses and sages. Those are particularly important, and on the other side of the Cascades in Washington State and Oregon. And by the way, also in British Columbia, really important. The bunch grasses and the sages way up into British Columbia in the interior.